So a while ago I made a video on setting up quick AAO labs using infrared, and I also did one on AAO Quick Start. But now that I'm not working with AAO and I'm doing all these deployments on top of OpenShift, there's a better tool for setting up quick labs, and I wanted to have a bit of a look through that tool today and explain how I'm using the MetalCube dev scripts to set up my OpenShift environments based on OKD, and how I'm then deploying OpenStack on top of that OpenShift environment. So let's take a look at what I'm doing. Alright, so here's the node I'm using to deploy MetalCube dev scripts. So what is it? This is just a Git repository here. So Git, look where I've cloned it from. Just cloned it from, well, my own fork of dev scripts, but you can clone it directly from the OpenShift MetalCube dev scripts project. So we'll just do a git fetch upstream. Rebase upstream master. Okay, so now we've got the latest code in this repository. So first thing we're going to do is just do a make clean, because I already have an environment deployed here. So basically this is just a collection of bash scripts that go and provision an OpenShift environment, or in this case OKD. It uses the MetalCube project, obviously, so we use Ironic to provision VMs and pretend that they're virtual nodes. And you can set up any number of nodes. We can have, three control plane nodes with any number of workers we want. We can have extra worker VMs. So this is a really handy tool for us to use while we're working on these OpenStack operators, where we might want to provision our control plane and our OpenShift workers, but then add an extra few VMs that we can use for our OpenStack data plane nodes. So we'll wait for this cleanup to finish, and then we'll take a look at the config file we're going to use, and basically the steps we need to walk through to deploy an OKD environment. I like to do things upstream because it's more consumable for a wider range of people, so we'll use OKD in this case. But it does work with OpenShift. The instructions for OpenShift are on the GitHub README. Okay, so all we need here is we just need a config file. So we've got one here called config-m3, and let's actually take a look. So we can see all I'm doing here is setting some really basic information. So the OpenShift release image. So all I've done to get that is I've gone to the release page for OKD. So this one here. So I've just gone to the release page for OKD and just picked a version. So for the best experience, I would recommend going to 4 stable. You go here, and then you can see here's the release image for it. Right, so we copy this release image down here, and we'll throw this away. We can see that that's basically what I've done there, so we'll just go config m3 and we'll change that release image. So we go export OpenShift release image equals, paste that one in. So that's the release image we're going to use here. Now I am setting a pull secret because I have a pull secret, and that just gives me access to the Red Hat operators catalog. So if you want that and you do have access to a pull secret, paste it in there. If you don't, it's fine. You just won't have access to the Red Hat operators in the catalog. The next thing we're going to set is just set release type to OKD so that we're deploying upstream. So if you don't do that, then what you need is this CI token at the top. And you'll need to browse to that URL. You'll need to be able to log in with a Red Hat credentials and get a CI token, which is not exactly accessible for the vast majority of people. So that's why we're sticking with OKD here. The next thing, let's go back to our grep because it's a little bit easier to see in a summarized form. So you can see I've set IP stack v4, v6 there. So I don't want to do any testing with IPv6 for this deployment. So I'm just going to change this to v4. So we'll only deploy with IPv4 for this deployment. The next thing I'm doing is just increasing the size of the master disk, so I have a little bit more storage that I can use on those nodes. Setting the number of workers to 3, and I'm doing the same for the workers. So I'm setting the disk to 90, I'm giving them 24 gig of RAM and 8 vCPUs each. And then I'm just adding 2 extra workers and doing the same for those. So they're a little bit smaller because I'm going to use those as the external data plane nodes for OpenStack once it's deployed. So if you were to just take exactly what I've got there, put it in your config file, and that's all it was, that should be sufficient to get this deployed. So the next thing, all you need to do, we just want to start a tmux session. So we'll just start a new one here, and we'll just run make. So that's going to run through that deployment. It's going to deploy OpenShift for us with those extra couple of VMs provisioned. And then we can register those as bare metal hosts or do whatever we want with them. So we'll just go through that deployment. I'll show you the setup of OKD, and then we'll wrap up the video there. So you can see that now the VM's being created. So we go over to this window and we do list. We need a sudo for that. Let's see what we've got here. So we've got our bootstrap node created there. And we'll just do an all. And we can see that it's created the control plane nodes, the worker nodes, and the 2 extra workers that I've asked for. So this is going through and it's going to start provisioning those now. So we can see here it's starting to provision them. So we just watch along here, list, sudo again. So we'll expect some of these to start booting soon, and we'll see that they pixie boot from Ironic just like they would if they were physical nodes and you were deploying them in a normal triple O deployment. Now I'm using Ironic, and we'll have a look at how we can get some information from those. So we can see that we're able to log into the bootstrap node just like we would be able to on any normal OpenShift deployment, and we can also follow along with the logs that are happening in here. So from this point on, if you were to have issues, it's basically just like debugging a normal OpenShift deployment here. So we can see that it's finished downloading the release image there. We'll just stop filtering out as much stuff and see what it's actually doing. So you can see it's extracting PXE files, it's preparing the PXE images that are going to be used for the nodes to then PXE boot. So you can see that things are starting to happen over on this side as well. So we just follow along with those logs for now, and we'll just see what it gets up to. And obviously the deployment is still running over this side. And we open a new tab, do sudo list. It still hasn't started up any of those, the VMs that it's created yet. So let's just follow along with these logs and see what it gets up to. So we can see what was happening there was it was saying there's no hypercube binary found, and it was also complaining about no OC binary being found as well. So what it's doing there is it's booted from a base image of CoreOS, and now it's rebasing on top of the OS tree image required to deploy OpenShift. So you can see that the node rebooted on me there. So we should be able to log back into that node soon. Yep, which is there. So we've checked uptime. We can see it's only just come up. So we should expect now that it has the RPMs installed, the OpenShift RPMs that contain Hypercube and OC. So we can see that it's able to make a bit more progress there this time. So we'll keep watching along and we'll see how it goes. So you can see here now we're starting to get some log messages coming back from Ironic. So we're starting the introspection of the nodes there. So let's go and take a look at what's happened over here. And we can see our master nodes have been booted. So we'll just versh console along with one of those. We might have already missed the boot up. So if you're familiar with what happens in an IPI deployment, basically the bootstrap node provisions the 3 control plane nodes. Then the 3 control plane nodes will provision the additional workers and any number that there may be. So these control plane nodes will come up, they will deploy all the control plane services on them, they will start keep alive D, they'll take ownership of the VIP from the bootstrap node. And from that point, basically everything is up to the 3 new control plane nodes. The bootstrap node's job is done at that point. So what we're watching here is we're watching our control plane master 1 node PXE boot from Ironic that's running on the bootstrap node, and then the workers will PXE boot from Ironic running on the control plane nodes once they're up and running. So I don't think we'll get a lot more output on the Versh console from this one in this case, but we can go back here and follow along. This will tell us if we get any errors. So we can see the DHCP ACK there that was sent to that node. We can see that it's inspecting the nodes now. So we just wait for Ironic to provision them. Go back here, we can see nothing has changed on the main install page where I run the command make. So we've been watching all this on the bootstrap node up to this point. So if we check now, we can see we have a kube config file. So what we're able to do is just copy that one to kube and config, and then we can do oc get co. And now we can see that the OpenShift API is responding from the bootstrap node here. So what we'll see in a couple of minutes is the nodes will become available on here, and we'll start to see services starting on those nodes. So for now, we'll check on the console. Nothing much is going to happen there. At that point, it's already loaded the command line arguments, and it's going to log all of the Ramdisk info out to a Ramdisk log file. So the best we're going to get at this point is just to follow along with the logs here and see if anything happens and starts to progress. We can also check the containers here, podman ps. You can see we have Ironic there. We have the Ramdisk logs container that I was referring to, so we can do podman logs on Ironic Ramdisk logs. So that's the boot sequence of the nodes and logging to the output in this container. So those Ironic containers will run in Podman, but the rest of the OpenShift services will be in cri-o, so we can just do cri-ctlps. And we can see keep alive there that I was referring to, so that will fail over to our new control plane nodes once they're ready to go. So there's not a lot here that I really want to get logs from. I'm just going to follow along with the journal logs in general. And what we should eventually see is these nodes will be shut down and started back up again, and they'll come back up with the core OS image they need to actually run OpenShift. So we'll wait a few minutes and we'll come back and check in soon. Been rebooted at this point, because we did console on 308, now it's 313 for that same node. So we'll give that a couple of seconds. Back here, OC get nodes. So they're still not registered yet. And we're not going to see any other cluster operators come up until those nodes are registered. Right, so we see there it's running the approve CSR script. So it's trying to approve any CSRs that come in for those nodes, which I don't think we have yet. We still don't have a prompt here. Doesn't mean much though, because they don't necessarily have the console on the serial port. And we can see on the main installer page where we run the make command that is just now waiting for bootstrap to complete. So we'll see that in these logs here. For my own sanity, I might just reboot one of these so that I can get some console output. But again, like, we shouldn't expect anything to happen too quickly here. They will be provisioned with the base OS. Then they'll get anything they need to be consistent with the version of RPM-OS they need to be running. So we're not stressed at this point. I just like to see something on the console for my own peace of mind to know that something is actually happening. We see in this case that node is now actually booting up. We go back over here, nothing much happening there yet. Okay, so we see that we've got a couple of nodes there now. Ironically, except for the one that I rebooted. So if I didn't reboot it, we would have 3 nodes there right now. So we'll just wait for that third one to join the cluster, and things will keep progressing. You can see there now that it is checking in with all the pod statuses. So we go back here and do OC get co. You can see that now this is also starting to make some progress. And we see that pods are starting up on those nodes. We'll just do a one. See the nodes they're running on. So we just need to wait for that master one to rejoin the cluster now. So you can see there, our cluster operators are starting to make a lot more progress now, so that's great. We have 3 ready control plane nodes. Machine config. Okay, so we look over here at our bare metal hosts. We can see that we're trying to register our existing 3 control plane nodes. So they'll come up as like pre-provisioned, provisioned externally. And these ones here will be provisioned by the new control plane. So we go back over here and do this. We should see those nodes start up soon. So we do OC-get-po- and openshift-metal3. You can see that this is where Ironic runs. It runs in the metal cubed pod. Might be called metal cubed ironic. Yeah. Okay, so we can see we've got some logs there now. So we're still just waiting at the moment. We'll keep hanging out. We'll wait for those next 3 worker nodes to show up, and we'll see how our cluster operators progress. We'll go back to our bootstrap node though and just follow along with those logs. Alright, so we're seeing here that our 3 worker nodes have started up as well. So they're now being provisioned, which is great. We do OC-get-bmh. We can see that it's inspecting those nodes now. And the only thing we're waiting for from a cluster operator perspective at this point, if we take a look at the pods that are still pending, we can see that they're the ones that are going to need to run on our worker nodes, so the routers, for example. So our cluster operators aren't going to make any more progress from this point until our next workers are available. So at the moment we're just hanging out, we're waiting for those workers to be available. And the job of the bootstrap node at this point is just to sign those CSRs when they become available. So we do OC-get CSR. We shouldn't see any here that are pending because they're being automatically approved at the moment. So still just waiting at the moment, but another update on how things progress, so you know what to expect when you're watching it yourself. So here we're seeing our nodes go from available into this provisioning state where they're being claimed by a consumer. Okay, so they're provisioned now, so we do OC-get nodes. They're not there yet. Verse list all, sudo verse list all. Okay, our worker nodes are up and running. So check CSRs. We don't have any CSRs yet for the worker nodes, so we're just waiting for them to start up, get the CSRs approved, and then join the cluster. And then at that point, we should start seeing things start to progress. And I just find this is a good command to get a good picture of what's happening. If you've got pods that aren't running or complete, they're either pending, crash loop back off, image pull back off, there's something wrong you need to look into. Pending is probably the best case because they're just waiting on something else to happen. And in this case, they'll be pending because they're waiting on a node to match their node selector. And we can check that. We do OC-describe, OpenShift-ingress on the router pod. This is just going to say no nodes match the node selector. Describe. PO. So 0 of 3 nodes are available. 3 nodes had an intolerable taint, which is the node role master. So we're looking for nodes that have the worker toleration. So that's all that is. So we're just waiting for those nodes to join our cluster now. It's interesting to be able to follow along with the BMH. You see the different statuses, the inspecting, they move into available, and then they get claimed by a consumer, and then into provision. So we do OC-get machines. We can see there, those are the 3 that were provisioned, and these are the 3 that were running previously, which are the externally provisioned control plane nodes. And they're just externally provisioned because the bootstrap node provisioned those ones. And if you wanted to check along any of the logs, you can OC-get-po, OpenShift, machine API. So just in that metal cube pod, so there's the the container we looked at when we were looking on the bootstrap node. We were looking at the Ramdisk logs container. So here it is here, same thing. This is the metal-cubed Ramdisk log. So all the Ramdisks from all the nodes will be logged here. So you can see here worker 0. You can see the disks that it found, for example, and all the commands that were run during that node provisioning process where it was running on the Ramdisk. So that's where you would get information from if you were having issues provisioning any of these nodes. It's going to be in the pods within the OpenShift-Metal API namespace. But thankfully, in this case, we don't have any issues. There we go. So we have one worker that is ready to join the cluster. And now we have all 3 workers that have joined our cluster, and we're just waiting for the CNI provider to start on those nodes so they come into the ready status, and we can start provisioning pods on them, which will clear up those last few pods that are sitting there in that pending status at the moment. And we can see we have a few more now as well that are creating on these new worker nodes. So SDN, these are important ones that are going to need to start up. Oh, interesting that I've deployed with OpenShift SDN. I normally don't do that. So if you wanted to change that, you can export network type OVNKubernetes, and that will use OVNKubernetes instead of OpenShift SDN. It's not really pertinent for what we're demoing here anyway, but just so you know. So our nodes are now ready there. So now our cluster operators will start to make progress from this point. If we do OC-get-bmh-a, no issues, still the same status. Machine config pool, we have 3 ready nodes now. So now it's just a matter of waiting for the deployment to complete, and we go back to where we were running the make command. We still wouldn't be seeing anything by this point. So we've obviously looked at a lot of stuff that you're not being shown in this output. I hope that has kind of helped to explain, where you get that information from at the various stages of that bootstrap and provisioning process. So we'll keep waiting at this point in time. We'll wait until those nodes have started up all their pods, and at that point we should be pretty much deployed. So we'll come back in a few more minutes and check on it. Okay, so our deployment has completed here. Now we can see all of our cluster operators are up and running. You can do OC-get cluster version. You see there it has now deployed the version that we set. So that is great. Let's go back to our makefile and see what our makefile's done. So we can see what it's done after that. Generate auth template. So I think this might generate our clouds.yaml file. It has. So that's generated our clouds YAML file. So what we can do now is copy that clouds YAML file into config, openstack, and then if we do export os cloud equals metal3, what we're able to do is openstack bare metal node list, so we can interact with ironic. So we can see there all the ironic nodes, but we don't really need to interact with ironic in this environment because what we have is the bare metal host interface provided by the machine API controller. So we can interact directly through MetalCube without having to intervene with ironic directly. That's all I've got in this video. So obviously I'm developing OpenStack operators and I'm using this platform to deploy consistent environments where I can do development work and test things out. I do have a home lab, but that has some bespoke networking requirements. It's got its own DNS servers, gateways. It's got its own, public resolvable DNS that it can use for the cluster addresses. So it's not always the best environment to get a clean, consistent development environment. It's great for testing things. It's great for using it in a way that's consistent with how customers and users will actually use the product. But when it comes to, I just want to reproduce something, this is how I'm doing it. I'm doing it with the MetalCube dev scripts because it's a quick way to deploy an environment, have the access to the bare metal APIs, and use MetalCube to provision my data plane nodes, and then I can use that in an environment that looks very similar to what you would expect with a bare metal environment. So hopefully that is a bit easier than what I've previously showed with infrared and OOO quick start. Hopefully that's a nice, easy way for you to get involved and start using OpenShift MetalCube dev scripts. As I said, I'm using OKD. That's more realistic for most of the people that will watch these videos that aren't working at Red Hat. So The only thing you would need to do if you want to use the Red Hat operators, you need to have a valid pull secret. So you need to be a Red Hat customer. You need to provide that pull secret in the config file. So you'll see how I've set it up. It's just a file on my disk. So just take another quick look at the screen here again. So I've just got a pull secret text JSON there. So we'll just remove anything that starts with a hash or any blank lines from our config. So we can see here that I'm just providing the pull secret JSON file. So export pull secret file, and then I've just put my pull secret file into that JSON file in this directory that I'm running main from. So I will leave all of this information, because this is what I just deployed with in this video. You should be able to do the same. I'll leave that in the description of the video below. But I think this is a great environment for if you're working with OpenShift in production and you want to do a test upgrade from 4.12 to 4.14, for example. This would be a really quick way that you can deploy something that looks like production. Maybe you want to deploy a few workloads on it and test how they're going in a more production-like environment, and then perform that upgrade and see what happens. It's a great way to get that exposure without exposing your production environments while you're still trying to learn things or understand what the consequences of some specific action might be. So thanks for watching. If you have any questions, drop them in the comments below. I'm happy to answer them, and I hope that makes your life easier.